Hi, this is Sir Amboy and welcome to my YouTube channel. So, this episode is the start of the lecture proper that I'd like to do for the course Differential Equations, and this is the course that I'm handling this semester. So, if you are an engineering student who are currently taking this course, this series of lectures and videos would be very useful for you. So Module 1 contains the important introductory concepts about differential equations, kung saan i-discuss ko ang mga mahalagang concepts kagaya ng definition, important terms like order, degree, linearity, and I'll be giving a lot of examples as well. Okay? So if you're ready, let's begin. First, let us discuss the need for differential equations. Why do students have to study differential equations? Of course, aside from the fact that this is a requirement for the students because this is one of the subjects that they need to pass in order to go on to the next level and take the subjects in the next semester, there is a deeper reason why we need to study differential equations. Okay, so differential equations is a powerful tool in solving many real-world problems in engineering, physical sciences, natural sciences, business, and even in economics. So if you recall, in my previous video, I gave a bigger picture of what differential equations is all about. Dun sa video na yon, I presented a lot of examples and applications of differential equations from engineering, physical sciences, up to applications of this subject for business and in economics. So, this is a very relevant subject as I have said. Kasi relevant siya sa mga pang-araw-araw nating pamumuhay, hindi lang natin nare-realize. Kasi ginagamit natin siya even in banking, in finance, of course in engineering. Now, let's narrow down the application of differential equations in engineering. What are the subjects that you will be taking in engineering which would require the knowledge of differential equations? First, differential equations is very important in electric circuit analysis. In Circuits 1, in the finals, you'll be studying transient circuits kung saan napaka-relevant ng differential equations. Ganon din, pagdating ng Circuits 2, gamit na gamit din ang differential equations. Another important subject kung saan gamit na gamit din ang DE is control and dynamical systems. So this is an important subject for electronics engineers, electrical engineers, mechatronics engineers, and of course, instrumentation and control engineering. So dito, ginagamit ang mga differential equations sa pagmomodel ng iba't ibang klaseng systems. It could be an electrical system, a mechanical system, or a combination of them, an electromechanical system. So in modeling those systems, we use differential equations. Next is the application of differential equations in mechanics. So whether it's mechanics of rigid bodies, kung yan man ay statics, lalo na sa dynamics, okay? There are lots of applications of differential equations in dynamics. Even in fluid mechanics, there are lots of applications of differential equations. So whether it's mechanics of rigid bodies involving statics and dynamics, or mechanics of fluids or fluid mechanics, differential equations is still very much relevant. What else? Differential equations is also relevant in electromagnetism. As I have said in the previous video, all phenomena involving classical electromagnetism can be described by a set of 4 equations called Maxwell's equations, and these are actually differential equations. Now, aside from electromagnetism, we use differential equations in wave theory, and this wave theory is very important in wireless communications. Now, you may think that differential equations is very much related to all of these subjects. It's very much important to all of these subjects. And of course, that's interesting. Why? Because these are some of the subjects that you'll be taking in the future, and all of them are related to differential equations. That's why this subject, DE, differential equations, not difficult equations, differential equations is a very interesting and relevant subject. So, first, halimbawa, given ang isang function. A function is given y equals 3x squared plus 1. Here we have two variables, x and y. So in this equation, we say that y is a function of x. So another way of saying that is y depends on x. That is why we consider y as the dependent variable. And the other one, x, is considered as the independent variable. Now, what if we want to get the derivative of y with respect to x? How do we write that? Of course, we use the familiar derivative notation. The derivative of y with respect to x can be written as dy over dx. Okay, so the variable na kinukunan mo ng derivative. Dito, ano ba ang kinukunan ng derivative? Yung y. Okay, so the variable which you are getting the derivative of is your dependent variable. No? At yung variable kung saan with respect to hinahanap ang derivative, yun ang independent variable. So tatandaan natin, ha? O, lagyan natin dito ng sulat. No? So this is your dependent variable. And this one is your independent variable. Ang shortcut dyan is, para madaling tandaan, yung variable na nasa numerator, yun lagi ang dependent. At yung nasa denominator, yun naman ang independent variable. Okay? So, tatandaan natin ha. We can also use the prime notation. So, y prime is the same as dy over dx. So, when we use the prime notation, it's implied that the independent variable is x because y prime is the same as dy over dx. Okay? However, if you are given a differential equation like this, y prime plus 3 y equals, for example, cosine t. So, in this differential equation, we have the y prime notation. However, here on the other side, we have cosine of t. So, that means that the prime notation does not have x as its independent variable. In this case, the independent variable is t instead of x. Okay? Kasi kita natin, walang x dito eh. Instead of x, ang ginamit nating variable ay t. So, here, y prime corresponds to dy over dt. Okay? Now, aside from the prime notation, we can also use the differential operator, capital letter D. Instead of d over dx, we can simply write dy. Okay? So, kapag sinabi pala na dy, yun ay derivative of y with respect to x. So, pag sinabi ko na du, yun ay the derivative of u with respect to x. Okay? Now, how do we write the derivative of a certain variable with respect to time? So, for example, we have the derivative dx over dt. There is a shorter way of writing this para bagang counterpart siya ng prime notation. Yun yung dot notation. No? So, we represent dx over dt as x dot. So, ano ang ibig sabihin nun? Yung dot notation, yun ay derivative with respect to t. So, that means x dot is the derivative of x with respect to t. So, if I have y dot, no? Itong y dot na ito, ang ibig sabihin niyan, that is the derivative of y with respect to t. Okay? So, again, you need to be familiar with these notations. Next, higher order derivatives. Kung gusto natin kuha ng second derivative ito, y with respect to x, gawin lang natin d squared y over dx squared. Take note that the square is after d. Pero dito naman, yung squared term ay after ng x. Okay, we can also use the prime notation. Kung gusto natin second derivative ng y with respect to x, we can use y double prime. No? Or, the differential operator, gawin natin yung d squared y. So, itong mga ito, isa lang ang ibig sabihin. They all mean the second derivative of y with respect to x. Now, another important notation is for partial derivatives. Although this course is all about ordinary differential equations, I'd like you to be familiar with the writing or on how to write partial differential equations. Ito pala, x double dot. Ano naman yung x double dot? So, that is the second derivative of x with respect to t. Okay? So, sulat natin dito ha. X double dot. Ang ibig sabihin niyan, d squared x over dt squared. Excuse me. Now, let's talk about partial derivatives. So, in writing partial derivatives, of course, we use the notation which is similar to letter D but not exactly letter D. Hindi siya straight, no? Parang ako. So, this is a second partial derivative of u with respect to x. And another way of writing that is using the subscript notation uxx. Okay? So, when we say, for example, uyy, this means is the second partial derivative of u with respect to y. Okay? So again, these are the notations for writing derivatives which we will be encountering in our succeeding topics. Now, let's define differential equations formally. Differential equations are equations containing derivatives. Or if not derivatives, they may contain differentials. That's it. Very simple. Kapag ang isang equation ay may derivative, or kung walang derivative, nagtataglay siya ng differential, ang tawag doon ay differential equation. So, halimbawa niyan is dy over dx plus 2xy equals 4. So, here, we have an equation. We have a derivative in the form of dy over dx. Okay? So, this is an example of a differential equation. Now, a differential equation may not have explicit derivatives on them. Instead, they have differentials. O halimbawa, meron tayong differential equation na ganito. 2xy squared dy plus, for example, x minus 2 dx equals 0. So here, we do not have derivatives expressed explicitly kasi wala ka namang makikita dito na dy over dx o kaya ay dx over dy. Instead, we have differentials dy and dx. But still, kahit wala iyang derivative, pero meron siyang differentials na dy at saka dx, we can still consider this a differential equation. Ang pagkakaiba lang nila sa equation na ito, sa unang example, ang derivative ay expressed explicitly. Samantalang dito, walang derivative. Instead, ang ginamit natin ay, again, differentials. Okay? Next. What do we have in a differential equation aside from it contains derivatives or differentials? Gamitin natin yung unang example. In a differential equation, there is actually a relationship between an unknown function, a certain unknown function, and its derivatives. Okay? So I'd like to give emphasis that a differential equation expresses a relationship between a certain unknown function and its derivatives. Or kung gusto mo, isa lang, derivative lang. So, gamitin natin ang example na ito. In this example, the unknown function na tinutukoy is actually y. So, kung ano yung dependent variable, di ba? Dito ang dependent variable is y. Yung unknown function na hinahanap dyan is actually y. So, anong meron? Ine-express niya yung relationship sa pagitan ng unknown function y at yung derivative niya. Ayan, no? Yung dy over dx. So, here, we have the unknown function y and its derivative. Okay? So, bukod pala sa ang differential equation ay isang equation na may derivative. Lagyan natin ng mas malalim na kahulugan yung meaning ng differential equation. Anong meron sa isang differential equation? Siya ay nagre-relate ng isang unknown function at ng kaniyang derivative. In a differential equation, there can be one or more derivatives. Anong ibig sabihin yan? In this equation, the only derivative present is y or dy over dx. But a differential equation can have multiple derivatives. Halimbawa, you have x squared y double prime plus 2y prime plus 3y equals 3 cosine x. So, in this differential equation, we have two derivatives, y prime and y double prime. And still, the unknown function is y. So, this differential equation relates a certain unknown function y, its first derivative, and its second derivative. And of course, we have the independent variable x. Ito, may x squared dito, at saka ayan, may 3 cosine x ka dyan. Now, aside from a differential equation may contain one or more derivatives, pag kumuha ka ng derivative, it is with respect to a certain variable. In this differential equation, our independent variable is just x. But a differential equation in general can have one or more independent variables. Anong ibig kong sabihin? Sa differential equation na ito, isa lang ang independent variable. X lang yun. Pero posible, sa isang differential equation, there are one or more. No? Halimbawa, ang isang differential equation may dalawang independent variables, x at y. Minsan tatlo pa, x, y at saka t. Minsan apat pa, x, y, z at saka t. Okay? And because we are talking about independent variables, we can actually classify differential equations into two. Any differential equation can be classified into two. What is the basis of classification? The basis is the number of independent variables. Okay, so what are these classifications? So we can classify a differential equation either as an ordinary differential equation or as a partial differential equation. So sir, anong pinagkaiba nila? Kapag sa isang differential equation, isa lang ang independent variable. Isa lang, kagaya nito. X lang. Ang tawag dyan, ordinary DE. Pero kapag ang isang differential equation ay may dalawa o higit pang independent variables, ang tawag dyan ay partial differential equation. Now, let us have some examples. For an ordinary differential equation, let me give you this one. di over dt plus 10i equals 2 cosine 40. So, in this differential equation, the dependent variable is I, and here the independent variable is t. Alone, isa lang, t lang. Kaya ordinary siya. Kasi isa lang ang kanyang independent variable. So here, the unknown function is I. No? And if you try to find the solution of the differential equation, its solution has the form I equals f of t. Okay? Yung solution ng differential equation na yan, ganito ang format. Now, another example for partial differential equations naman. So here we have the second partial derivative of u with respect to x plus the second partial derivative of u with respect to y equals to xy. So here, it's very clear that the dependent variable is u alone. However, we have two independent variables, x and y. So if ever I will be solving for the solution of this differential equation, its solution has the form u as a function of both x and y. Kasi nga po, dalawa ang independent variables niya. Unlike here, isa lang ang independent variable natin. Okay? So, it's clear. So, based on the number of the independent variables, there are two types of differential equations. We have the ordinary differential equations and partial differential equations. Now, itong course na ito, differential equations which you are taking right now is all about ordinary differential equations. Yung mga equation na isosolve natin, they are all ordinary differential equations. Ito, inaaral to sa advanced engineering mathematics and sometimes inaaral din sa grad school ng mga nagmamasters. Okay? Now, let's talk about the order and the degree of a differential equation. So, how do we define the order of a DE? Simple lang. The order of a DE is the highest derivative that appears in the equation. Yun lang. Kung ano ang highest derivative, yun na. Yung order ng DE. Okay? So, if the highest derivative is a second derivative, then that is a second order DE. If the highest derivative that occurs in the equation is a third derivative, then that is a third order DE. Okay? So, ganun lang siya kasimple. Now, what about the degree of a DE? So, yung degree naman ng DE, yan yung power ng highest derivative. Sir, ano ba ang ibig sabihin ng power? Sige, baka malito ka eh. No? So, this word power here also refers to the word exponent. No? Ang ibig sabihin niyan, hahanapin mo muna ang highest derivative. Kung ano ang highest derivative, aalamin mo ang exponent niya. Kung ano ang exponent ng highest derivative, yun na yung degree ng differential equation. Okay? Now, para mabigyang linaw ang mga ito, bigyan ko kayo ng examples. In this differential equation, ano ang highest derivative? So here we have a first derivative. Here, we have a second derivative. Of course, the order is the highest derivative. So malamang, ito ay second order DE. Okay? So this must be a second order DE. Now, how about its degree? According to the definition, the degree is the power, or rather, the exponent of the highest derivative. So, hahanapin mo muna ang highest derivative. No? The highest derivative is this. Second derivative. Ano ang exponent niya? Hindi ito. Kasi itong 2, yun yung order ng derivative mo. Di ba? Second derivative yan eh. Hindi yan yung tinutukoy natin na power or exponent. Pero, actually, 1 yan eh. Bakit? Di ba, for example, meron kang y squared. Anong exponent niya? 2. Y. Anong exponent niya? Hindi nakalagay. Pero understood, alam na natin 1 yun. Kagaya dito. So, ang exponent ng second derivative ay 1. Hindi na siya nakalagay kasi nga 1 lang. Para bagang, alam nga namang ilagay mo y to the first power. No? Hindi na natin ginagawang y to the first power yon. Y lang. Simply y. And if it doesn't have any exponent there, it's understood that the exponent is 1, just like here. So the second derivative here does not have any exponent. That's why it's understood its exponent or power is 1. So that means that this is a first degree differential equation. Second order, first degree. Okay? So ito ang exponent niya 3. However, although 3 is greater than 1, this is not the highest derivative, no? dy over dx, sir, naka-cube siya. Di ba mas mataas yung cube kaysa sa dun sa exponent niya na 1? Yes. However, according to the definition, the degree is the exponent of the highest derivative. And the highest derivative here is the second derivative, not the first. Okay? So, I hope that's clear. So, how about this second example? Ry double prime equals the quantity 1 plus y prime squared raised to 3 halves. Okay. So, of course, the highest derivative here is the second derivative. So, this must be a second order DE. How about its degree? Okay, you might say that, sir, parang nakalagay dyan, y to the 1 yan. Y or r, y double prime raised to 1. So, kagaya kanina, this must be a first degree equation. Okay? Actually, it's not. Hindi ito first degree. Bakit? Kasi, hindi ko nabanggit kanina yan, no? After the equation has been rationalized and cleared of fractional powers. So, in this differential equation, we have an exponent that is in fraction form. So, before we classify the differential equation, kinakailangan walang fractional exponents. And how are we going to eliminate this fractional exponent na 3 halves? So, what we will do is we can actually raise both sides of the equation to 2. I-square natin both sides para mag-cancel yung 2 dito at yung 2 doon. Okay? So, squaring both sides, we will get r squared, of course. And then we have y double prime also squared equals the quantity 1 plus y prime squared and then cube. Okay. So, this is now the differential equation that we would like to analyze. Okay, so ngayon, ang highest order niya or highest derivative is y double prime. Anong exponent niya? 2. So this must be a second order, second degree equation. Okay, palabasin natin. So once again, this is a second order because the highest derivative is a second derivative, and second degree because the exponent of the second derivative is 2. So again, before you determine the degree of a differential equation, if there are fractional exponents, you need to eliminate and rationalize all the fractional exponents. Aside from order and degree, we can also classify differential equations as either linear or non-linear. And this is very important. Why? Because during examinations, there might be questions that goes like this. Which of the following equations is linear? Or which of the following equations is non-linear? O, diba? So, para masagot mo yung mga ganyang klaseng tanong, kinakailangan alam mo yung concept. So, a differential equation is linear if the dependent variable and its derivatives are of first degree. Kung first degree yan, dapat ang dependent variable, ang exponent niya ay 1. Halimbawa, meron kang dependent variable na y. Kapag nagkaroon ka ng expression na y squared, 1 over y, y cube, lahat yan ay dahilan para maging non-linear yung differential equation mo. Again, if your dependent variable is y, kinakailangan yung differential equation mo, ang dependent variable daw, at yung kanyang mga derivative ay first degree. So, halimbawa, yung iyong y prime ay nagkaroon ng square. Yan ay non-linear na. Bakit? Kasi yung derivative ng y ay hindi na first degree. Another important thing, dapat lahat ng dependent variable ay linear functions ang involved. So, if in a differential equation whose dependent variable is y, nagkaroon ka ng term na sine of y, ln of y, e raised to y, these are all non-linear functions of y, which is the dependent variable, and the presence of these terms in a differential equation whose dependent variable is y will make the equation non-linear. Okay? Second rule, coefficients naman. What do we mean by coefficients? Yan ang multiplier ng derivative at ng dependent variable. So, para daw maging linear ang isang differential equation, dapat daw lahat ng coefficients ay constant. So, kung hindi constant, it should be a function of the independent variable. Kanina ang tinitingnan natin yung dependent variable mismo. Dapat yung dependent variable ay linear. At saka yung kanyang mga derivatives. Ngayon naman, ang susunod nating titingnan, yung coefficients. Ano yung coefficients? Multiplier ng y prime, multiplier ng y double prime, at saka multiplier ng y. So, yung mga coefficients daw na yan, kinakailangan ay constant. Or kung hindi man sila constant, ay di function. It should be a function of the independent variable para siya ay maging linear. Okay? So, let us give some examples to clarify. Halimbawa, dy over dt plus y equals 0. So, here, the dependent variable is y. And of course, the independent variable is t. So, ang multiplier niya dito ay 1, which is a constant. So, valid siya na maging linear. Dito, ang dependent variable mo, ang exponent ay 1. So, this is very obvious that this equation must be linear. Okay, now let's have another example. So, the only difference is that here, we have y, and now here, we have y squared. So, remember, here, the dependent variable is y. And here, we have y squared. And this y squared is a non-linear function of the dependent variable. So remember, in order for a differential equation to be linear, the dependent variable must be of first degree or linear. Hindi na nga first degree siya eh. Second degree na ito. Kaya ito ay non-linear na. Next example. Here we have dy over dx plus x squared. Sir, may x squared non-linear siya. Okay. However, although naka-square yan at yan ay non-linear, yung x ay independent variable. So, since it is independent, kahit pagawin mo yan x cubed or x to the 100, independent variable siya. Still, this equation is linear. Anong pinagkaiba dito? Dito ang naka-square ay dependent variable. Dito ang naka-square ay independent variable. Magkaiba sila. Kung independent variable yan, kahit pa yan ay naka-cube o naka-square or naka-raise to 5 or whatever exponent, wala tayong pakialam kasi independent yon. Kaya ito linear pa din. Pero ito, ang naka-square ay dependent variable. And that is the reason why it became non-linear. Okay? Now, next example. So, itong x squared na ito, walang kaso kasi kagaya lang siya nung kanina. So, dito, kung ikukumpara natin yung dalawa, ang may kaso dito, ito, kanina, ang multiplier ay 1. No? Yung coefficient dito, 1. Dito, y. Anong sinasabi tungkol sa coefficient? Dapat daw ang coefficient ay constant. Or if not a constant, it should be independent variable para siya ay maging linear. But in this case, the multiplier or the coefficient is y, which is a dependent variable. And that makes the equation non-linear. Bakit? Kasi po, kapag ang dependent variable iminultiply mo sa kanyang derivative, ang equation ay nagiging non-linear. Okay lang. Halimbawa, kung yan ay maging x dy over dx plus x to the 5 equals 0. Kahit ang multiplier ko dito ay variable, okay lang, no? Linear pa din yan. Bakit? Kasi po, yung x ay independent variable. Ayan, no? kung ang ating coefficient ay independent variable, still the equation is linear. But if the coefficient becomes dependent variable, nagiging non-linear ang equation. Let us have some more. X squared y double prime minus x minus 1 times y prime plus 8y equals sine of 3x. Let us analyze. Ano ang mga coefficient dito? So, ang coefficient natin x squared, x minus 1 at 8. No? So, these are functions of the independent variable x. Ito naman constant. Okay? So, dito, ang kinuna natin ang sign, independent variable din. Okay lang yan. So, linear pa rin yan. No? So, we have here y double prime, y prime, and y, which are all first degrees. That is why this equation is linear. So, magiging non-linear yan. Kung example, halimbawa, ito, gagawin mo siyang sine of 3y. Another example. So, here we have x double dot plus, napasobra yung plus, dapat isa lang, plus t squared x dot plus 2x equals e to the negative 2x. So, if you recall kanina, sinabi ko yung dot notation, that is the derivative with respect to time. So, actually, we can rewrite this equation as d squared x over dt squared plus t squared dx over dt plus 2x equals e to the negative 2x. Or let us analyze. So here, the dependent variable is x and the independent variable is t. So dito ang coefficient mo ay 1 constant. Dito ang coefficient mo ay t squared, independent variable. Dito meron kang 2x. O ang x naman, dependent variable, ang power niya ay 1. So, linear pa rin yan. Pero, shit! Nagkaroon ako dito ng isang term, e to the negative 2x. And here, x is a dependent variable. Dependent variable yung x mo at meron kang e to the negative 2x. And this is a non-linear function of the dependent variable. This makes the equation non-linear. Okay? So again, ang equation na ito, non-linear because of this term. I hope that it's very clear to you how to distinguish linear and non-linear differential equations. Okay, so let's have a recap. So far, kanina, meron tayong classification ng differential equations depending on the number of independent variables. Is either, kung isa lang ang independent variable, ayan ay ordinary, kaya partial differential equation. Kung maraming independent variables. And then after that, meron tayong order at saka degree. Yung order, that is just the highest derivative. Yun namang degree, yun naman ay exponent ng highest derivative. And now, ang topic naman natin, linear at saka non-linear. Okay? Now, ano ba ang kahalagahan ng linear at non-linear equations na ito? Actually, mahalaga yan eh. Why? Because life is mostly linear. Ang gusto kong sabihin dito, sa mga practical applications na common sa engineering, most of them are linear differential equations. And in most cases, they have constant coefficients. Okay? So, linear differential equations with constant coefficients. And there are also some cases that the equations that we have are linear. However, linear, they are just approximate versions of more complex nonlinear equations. And although they are approximate versions, they are sufficiently accurate for most purposes. Anong ibig sabihin nito? Minsan daw, sa totoong buhay, ang accurate or actual na equation or differential equation ng isang system ay nonlinear talaga. However, gumawa tayo ng approximate version na linear. Sir, bakit ba tayo nag-approximate? Nonlinear siya talaga. Bakit mo ginagawang linear? Okay, so the answer to that is for us to easily find the solution of the differential equation. Why? Because the theory of linear differential equations is well established already. So, practically speaking, if your differential equation is linear, kahit ano pang differential equation yan, basta linear, kaya natin yan isolve. Because again, the theory of linear differential equations is well established already. Kaya ang ginagawa natin, kung non-linear ang isang differential equation, gagawa ka ng paraan para mas madali siyang isolve. Now, to give you a practical example, let us consider a simple pendulum. For example, yan yung pendulum mo. Di ba yung pendulum nagsusway yan? Up and down. Okay? Up and down. So, halimbawa, ito ngayon yung pendulum mo. Yan. Gumagalaw siya. So, of course, this is the equilibrium position here. The angle theta is 0. So, ito ngayon yung angular displacement niya. Gumagalaw-galaw yan. Bawiin natin to. Pangit siya eh. Parang ikaw. Ay, joke. So, yan yung theta niya. So, this simple pendulum having a length L. Of course, this is subject to the force of gravity. Meron siyang acceleration due to gravity. Can be modeled using a differential equation. Ano ang differential equation ng simple pendulum? So, ito ibibigay ko na L d squared theta over dt squared plus g times the sine of theta equals 0. So, for the meantime, hindi ko muna explain kung paano siya ginawa. Basta for the meantime, yan na muna yung differential equation ng simple pendulum. Kung saan, ang dependent variable natin is yung theta at ang ating independent variable ay t. So, dito, yung mga parameters na L at saka G ay constant yan. Kasi habang nagsusway naman yung pendulum, itong length na ito, hindi naman nagbabago yan. And of course, this G is constant. It's the acceleration due to gravity. Kaya nga sinabi natin kanina, most ODEs that arise have constant, yan yung constant coefficient na sinasabi. Okay? However, kung napapansin mo, itong equation na ito ay non-linear yan. Okay? Sige nga, isipin mo, bakit siya non-linear? So remember, here the dependent variable is theta. And we have the term sine theta. And this is the reason why the equation became nonlinear. Because sine theta is a nonlinear function of the dependent variable theta. Okay? However, may workaround dito para siya ay maging linear. Ang tawag doon, linearization. So paano mo siya i-linearize? Mag-i-impose ka ng condition. No? So ano ang condition? Kung ang theta ay maliit, if theta is small, halimbawa, yan, yung angle na yan, less than 10 degrees, halimbawa, maliit lang. Kapag kinuha mo kasi ang sine ng isang angle na napakaliit, the sine of theta is approximately equal to theta. Actually, you can verify that using a calculator. Get a calculator and input sine of something. Dapat naka-radian mode ka ha. For example, sine of 0.2. No? So, this is an angle 0.2 radian, at ang makukuha mong sagot dyan, sigurado ako, approximately equal din sa 0.2. So, if we impose the condition that this angle is small enough, then I can replace sine theta with simply theta. Para maging ang equation natin is L theta double dot plus G theta equals 0. So, this differential equation is now linear. Okay, yan ang sinasabi dito na sometimes they are just approximate version. So, ito yung tinatawag nating approximate version ng isang mas komplikadong non-linear differential equation. However, although this is just an approximate version of the actual non-linear equation, this equation is sufficiently accurate for most purposes. Okay, now, let's talk about linearities. Bakit ba mahalaga ang non-linearity? Sometimes, non-linearities are important. Why? Because they are involved in the design of structures. So, there have been some significant failures because non-linearities were not understood properly. For example, if you have heard of the bridge which collapsed as it shakes, the bridge is actually shaking, moderate, actually, hindi naman, in moderate winds. So, the Tacoma Narrows Bridge collapsed. Now, here are some examples of differential equations. So, first, we have this equation in which the dependent variable is P and the independent variable is T. So, here, K and M are actually parameters which are constants. So, this is what we call the logistic differential equation, which is used in determining the population in a certain region. So, pag-aaralan natin yung differential equation yan sa module 3. Okay, logistic differential equation. And this differential equation can be classified as either linear or nonlinear. Okay, can you guess if this equation is linear or nonlinear? Of course, this is first order, no? First order, first degree. But is this equation linear or nonlinear? Okay, so here, the dependent variable is P. Imumultiply mo daw siya dito sa term na ito eh. So kapag yung KP, minultiply mo sa 1, KP pa rin siya. Pero kapag itong KP, minultiply mo dito, magkakaroon ka ngayon ng ano? So we have dP over dt equals KP minus KP squared over M. Okay, so here we have a term containing P squared, and P is a dependent variable. So that makes the equation non-linear. So remember that the logistic differential equation is a non-linear differential equation. Next example, d squared x over dt squared. Okay, so this is a popular differential equation actually in mechanics. If this x represents the position, the second derivative of the position with respect to t, of course, is actually acceleration yan, di ba? Second derivative ng position, acceleration. So, that means to say that this equation simply states that the acceleration is just proportional to x. However, its direction is opposite because of the negative sign. So, here, omega is just a constant na pag-aaralan natin in the future. And this equation represents the acceleration of a body in simple harmonic motion. Now, this is second order, first degree. Ito ba ay linear or nonlinear? This equation is linear. No, linear siya. Sulat natin dito, linear ang equation na yan. Next equation, we have, ito yung example ko kanina sa pagdedetermine ng degree. Actually, ang tawag dyan ay, yan ang equation ng radius of curvature. So, obviously, yung y prime mo naka-square. At kapag in-square mo both sides, itong y double prime, magkakaroon din ng square. So, obviously, this is a non-linear differential equation. Next example is a partial DE. So, in this partial differential equation, we have here u as your dependent variable, and here, we have two independent variables. No? Ayun. Yung x at saka t mo, these are your independent variables. So, how about this v? So, this v must be a constant. Now, this is a second order partial DE, which is also first degree. Now, is this equation linear or non-linear? Ang exponent niya dito 1, ang exponent niya dito 1, o di ba? That makes the equation linear. So this partial differential equation is linear. And as a matter of fact, this equation is quite popular in partial differential equations. It's called the wave equation. Now, to be more specific, it's the one-dimensional wave equation. Why? Because it only involves one dimension, which is along x. So, kung gusto mo, pwede mo siyang gawing three-dimensional wave equation. So, kung three-dimensional yan, x, y, z yung variables mo. Magiging ganito siya. The second partial derivative of u with respect to x squared plus second partial derivative of u with respect to this time y naman plus the second partial derivative of u with respect to z equals 1 over v squared times the second partial derivative of u with respect to t. Ayan. So, this is now what we call the three-dimensional wave equation. And remember that this equation, no matter how complicated it may look like, is still linear. So, this time, mag-practice na tayo para mag-determine ng order at degree ng mga differential equations. Aalamin lang natin kung ano ang order at saka degree, ha? Okay? So, number 1, 5y prime equals cosine x. So, obviously, this is a first order differential equation at the same time first degree. So, lagay natin first order, first degree. Next, lagay ko na lang yung number. Kung first order 1, kung second order 2. Highest derivative is second derivative. So, second order yan. And then, ano ang kanyang degree? Y double prime, ang exponent niya 1. So, first degree yan. Next, So here, the highest derivative present is y prime. So that means first order yan. Here, y prime is squared. So, siya ay second degree. Next. So, ano ang highest derivative? Highest derivative is second derivative. So, second order siya. Next, ano ang highest derivative? Second derivative. Ano ang exponent niya? 2. That's why it is second degree. Okay? So now, let's talk about linearity. I will give you several differential equations and we will now classify whether the equation is linear or nonlinear. Okay? So first example, y prime plus 2y equals x squared plus 1. So here, the dependent variable is y. So wala naman tayo ditong multiplier na y. No? Dito ang ating coefficient ay 1, dito 2. Both are constants. Although ito ay naka-square, ito naman ay independent variable. So still, this equation is linear. Next example, y double prime minus 5e to the y prime plus 3t. So in this example, t is your independent variable. Okay? And the dependent variable, of course, is y. But here we have a term involving e to the y. And remember that e to the y is a nonlinear function of the dependent variable. So this makes the equation non-linear. Kasi meron tayong nonlinear function, again, ng dependent variable. Next. Y double prime minus 4y prime minus 5t squared. So, kagaya kanina, here, your dependent variable is y. And t is your independent variable. Independent variable. So, is this linear or non-linear? Although ito ay naka-square, siya naman ay independent. No? Kaya, at the same time, this equation is still linear. Let's proceed to the next example. Here, we have the fourth derivative of x. Second derivative of x with respect to t. Tapos meron tayong t squared. So, dito may multiplier tayo na t. But this is independent, right? And here we have t squared. Although this is squared, again, this is an independent variable. Kahit naka-cube pa yan, kung independent variable yan, this equation is still linear. Magiging non-linear yan if ever, halimbawa, itong t, ginawa kong x. Yan. If this instead is x, d squared x over dt squared, this will become non-linear. Next example. So we have a partial differential equation. uxx plus u times uyy is equal to sine t. So here, our independent variables are x, y, and t. And the dependent variable is u. However, here we have a term u. Yung u, minultiply mo sa derivative niya. And that is the reason why this differential equation is non-linear. Why? Because again, here, the coefficient is a dependent variable. When you multiply the dependent variable to its derivative, the equation becomes non-linear. Okay, so last example. We have uxx plus sine of u times uyy equals cosine t. So again, this is a partial DE, wherein our independent variables are still x, y, and t. So, is the equation linear or non-linear? Here, we have a term sine u. And sine u is a nonlinear function of the dependent variable u. That is why this equation is also non-linear. Okay? So, we're done for the first part of Module 1. Sa susunod na lecture, which is lecture 1.2, we will discuss the solutions of a differential equation. Okay? So, see you again in my next video. Bye!